Okay, in the next few sections, we're going to be solving systems of equations. We're going to do them a few different ways. The first way we will be solving them is by graphing. Before we start solving these, let's figure out what the heck they actually are. What is a system of equations? This isn't in your notes, but I absolutely want you to write it in them. So maybe on that left side where you've got room for questions, put some notes down there. I want you to know what a system of equations is if you don't already. All it is two or more equations that you're going to solve together. In the last section, we were working with systems of inequalities. It was two or more inequalities that are solved together. We generally only do two of these, but it is possible to have more. In Algebra 2, you'll get into systems with three, either equations or inequalities, but in Algebra 2, we mainly stick with two. However, by definition, you could have more. What's the solution to a system of equations? Well, when we were doing the inequalities, it was where the shading overlapped, where their shading was in common. For a system of equations, when you graph an equation, you're only going to have a solid line. You're not going to have any shading. So it's still going to be what they have in common, but in this case, it's just going to be a point. And it's going to be the point where the lines intersect. It's the point that the two lines would have in common, and it's their intersection point. Okay, those are two important things to know so that you're not just sitting here going through problems and you're not really understanding what you're finding. This is what you're finding. You're finding the point where two or more lines would intersect on a graph. When we're talking about the solutions then, if we have two lines on a graph, here's a line, and maybe I have another line going like this. Well, the point where they intersect could be one point just like that. And if that's the case, then you have one solution to your problem. Think about other ways that you could have two graphs or two lines on a graph. Maybe you have one that goes here, and maybe your other one is perfectly parallel to your first line. We know parallel lines are never going to intersect. They're never going to touch. Well, if your solution is the point where they intersect, and we're saying that the lines are never going to intersect, then we would get no solution. And then what if you had a graph where you have one line like this, and the other line is directly on top of your first line? How many points do they have in common then? Every point on the line would be in common, so then we would have an infinite number of solutions. However, sometimes students think that when you have infinite solutions here, it means literally every single number would be a solution. But would this point be a solution to that? No, it would not be. It would only be the points that are on the line. It just so happens that we know a line has an infinite number of points. Okay, so yes, it's an infinite amount of solutions, but it's not every point. It's only the points that are on the line. So three different things can happen when you are solving a system of linear equations. You could get one single solution, one single point. You could have parallel lines and therefore have no solution. Or you could actually have the exact same line, and then you would have all of the points on that line be a solution. The most common one that's going to happen in your problems, of course, is one solution, but these other ones can come up as well. All right, let's get into some examples. So I'm telling you right from the beginning, these first two examples, you should end up with one solution. So if you're not coming up with that, you're doing something wrong. On the first one, these two are already in slope-intercept form, y equals mx plus b. That's what we want because that is how we will be able to graph our lines. So for your first line, your first graph, you would have a y-intercept of -3. So we go on our y-intercept and we plot a point at -3. Your slope is right here. It's the m. If we make that a fraction, it's 2/1. So that tells us to go up 2 and right 1. And I want you guys to do that a few times, okay? Because we're going to have to find the exact point where they intersect. So by doing this, we have exact points plotted. And what I mean by that is, say we only did these first 2 points. I could have maybe, well, maybe I would have graphed my line like this. Because, I mean, I'm a little messy. I'm not perfect. I know you guys think I am. And I know sometimes I think I am. But I'm not. Okay, so maybe my line looks like this. Well, look at how far off that gets from the actual, where the points actually should be. So to make sure you're drawing a as good of a line as possible, put in those extra points. Even with a straight edge, sometimes we can't get it perfect. So make sure you put in as many points as you can. Okay, then I can just follow those along. All right, for the second one, my y-intercept is 2, so on my y-axis I am up 2. And my slope is negative 1/2. Remember that negative either goes to the top number, the bottom number, but not both. Okay, so I'm going to put it in my top. I think that's the easiest, putting it with a numerator. Hot tip right there. Negative 1, right 2. So down 1, right 2, and immediately I find a point they have in common. Okay, so as soon as I do that, I can go ahead and just draw that line in. Whoa, I'm going crazy here. Hopefully your lines look a lot straighter than mine. And then the solution is where that intersection point is. So that ordered pair, the x value is 2 and the y value is 1. Again, make sure that you are paying attention to the fact that slope is rise over run, so it's your y value over your x value, whereas your ordered pairs, you do your x value and then your y value. Okay? All right, can you check these? Absolutely. You have an x and a y as your answer. It's a point, so you have to have both. And you can simply plug those in to your original problems. You would need to plug them into both to make sure they work. Okay, so my y value, so my check here, check, y is 1, 2 times x is 2 minus 3. So I'll obviously have 1 on the left side. This would be 4 minus 3, which is 1. Okay, so this point did work in my first equation. And what that means is 2, 1 is a point on that line. Let me do it with my second one. So I have y equals 1, negative 1/2 times x, which is 2, plus 2. Well, negative 1/2 times 2 would be negative 1. Negative 1 plus 2 is positive 1. So that checks as well, which means 2, 1 is also a point on this line. Well, if it's a point on both lines, we assume they intersect there, and that is your solution. Okay, our solution checked. Okay, the second one, our two equations are in standard form. They are not in slope-intercepts. They are not in y equals mx plus b form. So that makes it harder to graph. Doesn't make it impossible to graph, it just means that you need to manipulate your equations and get them into slope-intercept form. So for your first one, I'm going to rewrite it over here so I have some room to work. We need to get it into the form y equals mx plus b. We need to get y by itself on the left side of the equation. In order to do that, you need to subtract 2x. Doing that on both sides. Those cancel, and then we have y equals, what order would make sense here? 1 minus 2x or negative 2x plus 1? Hopefully you said negative 2x plus 1 because that would be in the form mx plus b. You want your x term to come first before the constant number. There's nothing else with the y, so we don't have to divide anything. We are done. Your y-intercept is positive 1. From there, your slope, you need to make it a fraction, would be negative 2 over 1, so that would be down 2, right 1. Do that a few times. You can even go backwards, going up and left, up 2 and left 1, and putting your line in. Sorry, it's very hard for me to go straight on this. Okay, you guys take the second equation, put it into slope-intercept form and graph it, and tell me your point of intersection. Pause the video and do that now. Okay, hopefully you've done this problem on your own. Hopefully you got 2, -3. If not, let's go through it real quick. You would subtract x on both sides. We're trying to get y by itself. And then you would want it in the order -x minus 4. At that point, you have 2 times y, so we need to divide by 2. When you divide by 2 on the right side, you have to remember, when you multiply or divide in equations, you're doing it by everything in the problem. So this essentially is a heart problem. Sometimes students will be like, -x/2, what do I do with that? But you have to remember, that's really -1x/2. And you can always take that x and move it off to the side. So you could make it -1/2 x. Okay, this is a common issue for students, so make sure you understand that you can do that. The reason you can do that is because this is really x/1 then, and to multiply fractions, you just multiply across the top. -1 times x would still be -1x or -x. So just pull that x off to the side. Then the second piece of it, -4 divided by 2, gives you -2. So -2 is your y intercept, and then your slope is down 1, right 2, which leads you to your point of intersection. Over 2, down 3, there is your answer. Of course, you could check it by plugging it back in and ensuring that it works in both equations. All right, let's talk about what a no solution problem would look like. So again, you are starting in standard form. You need to go ahead and get that into slope-intercept. So we would begin by subtracting x. Do that on both sides. We get -y equals -x plus 2. Make sure your x term comes first. And this is not done yet because it's a -y. You need to divide by a -1. Got to get rid of that sign. So those would cancel. Now I have y by itself. And then we're doing a heart again. So this piece, 2 negatives, would become a positive. And then here, +2 over -1 is -2. Y-axis, y-intercept is -2. What's my slope here? There's no number. I know that's an invisible 1. So 1 over 1. Up 1, right 1. Up 1, right 1. Up 1, right 1. You could also go the other direction. Draw your line in. Oh my gosh, so bad. You guys pause the video. Whoops. Pause the video and deal with the second equation. Figure out what your point of intersection is. Okay, check out what I have. When I rearrange my second equation, I got y equals x plus 1. And what you should notice about these is they have the same slope. They're both slopes of 1, and they have different y-intercepts. That means you're going to end up with parallel lines. Okay, so a no solution problem. Let me type it out. No solution problem will have same slope, different y-intercepts. And that is because they will create parallel lines. Okay, so every no solution problem will end up like that. Same slope, different y-intercepts, which means they are parallel lines. Okay, I'm going to let you guys do example 4. Do the whole thing by yourself. You know you're going to end up with infinite solutions. See what that looks like. Okay, I manipulated both of my equations to get them into slope-intercept form, y equals mx plus b. And notice that when you do that, both of them have the same slope-intercept form. Okay, so when you graph it, it's the exact same line. So infinite solutions will always work out where you have the same slope and the same y-intercepts. Can't type here. Because you really have the same line. Okay, that will always be the case for these. Okay. Make sure you're doing that little heart piece correctly. So in this first one, when I had negative 3x divided by negative 9, that's not 3. The smaller numbers on top, the bigger numbers on the bottom, that means you're going to end up with a fraction. Okay, same thing here. You had negative 1x divided by negative 3. That's positive 1/3 x. You can always use your calculator if you're afraid you're going to mess that up. Type it right in, negative 3 divided by negative 9. You just have to leave the x off and then put the x back on at the end. All right, so this is what solving systems of equations looks like. You could have one solution, infinite solutions, or no solution. You're simply getting your equations into slope-intercept form and graphing them, seeing what they look like when you graph them, whether they intersect or not. Okay. What do you think would happen if when you're solving these, they did not intersect at a nice, neat point? So say they intersect, but maybe they intersect at like right here, in between, in the middle of one of these little grid boxes. That's going to be not, you won't have a precise number just with this method. In the next two sections, we'll learn algebraically how to get the precise number, but we can also do it with the help of a graphing calculator. Okay, so I'm going to give you the instructions to use a graphing calculator on this. However, the directions in your packet are for a TI-83 or a TI-84 graphing calculator. We happen to have not that type in class, we have TI Inspires. So you will need different directions. Write them down on the lines under the TI-83, TI-84 directions or on a separate sheet of paper, but I will want to see them when I check your packet to make sure you actually did that and you have them ready to go. So you can refer back to them. After you do this several times, by the time you get to the end of your packet, you should have the directions memorized because you'll do it enough times that you will know how to do it without looking back at them. Step 1, and by the way, pause the video as needed to write the directions down. Step 1, solve each equation for y by hand. So you have to have it in y equals mx plus b form in order to graph. So for example 5 here, the first thing you would need to do is to subtract 2x. Then you get y equals negative 2x minus 7. Again, making sure your x term comes first. Second equation, you would begin by subtracting 5x. And we get 7y equals negative 5x plus 7. And then you'll divide it all by 7. Y equals the first piece, the first division is just negative 5/7x, that doesn't reduce. And the second piece, positive 7 over 7, is 1. Okay, let's graph it by hand just real quick to see why we might want to have the calculator help us. So for the black line, the black equation, 1, 2, 3, 4, 5. Well, first of all, we're off our graph, but let me just add on to it and say we'd be here. I'd be going down to right 1, which is even more off my graph, or up to left 1. Okay, so the first reason you might want a graphing calculator is if you don't have your grid big enough to hold your graphs. And I know that line's super crooked, sorry. Second one, positive 1, and you'd be going down 5, right 7. Okay, so we're like somewhere over here, right? So I'm assuming they're going to be intersecting somewhere back here, but it's really hard to tell because it's off my graph. It's off my grid. Right? That's the first issue. And the second issue is, what if they're at decimals? What if they're not at nice, neat, whole numbers? Okay. All right, so let's get back into the calculator. I'm going to expose these. I would probably, if I were you, pause the video and write all this down and then go through it with me. So I'm going to bring up a calculator and show you exactly what to do. So step 2, from the home screen. So if you're not on the home screen, if you are anywhere else, like in your calculator screen, press the home button. You want to select B for graph. Okay, you can either use your little mouse pad to get there, your little finger pad, or you can just type in B right there. Now it's quite possible you have some stuff on your graph, so we want to clear anything that is there. To do that, you go to Menu, Option 1 for Actions, Option 4 for Delete All, and then Enter to say yes, we want to delete everything. That should clear everything off your screen. Now you might have a weird window. You might have not just -10 to 10 here. You might have some crazy big numbers or even crazy small numbers. So we want to always start with a standard viewing window. To do that, Menu, 4 for window zoom, and 5 for zoom standard. Okay? And then you have a normal window from -10 to 10. Some of the calculators could vary in what the y value is. That's okay. Don't worry about that. All right, so now we are ready to type in our equations. So to get the box up to type those equations in, you're going to press Tab right here. This says f1 of x. We haven't done a whole lot of talking about this yet, but that's just function notation. And f of x, f parenthesis x, means the exact same thing as y. So this essentially already says y equals. You just need to type in the rest of your first equation. So for us, it was -2x minus 7. So negative, make sure you have negative, not minus, -2x, whoops, not two of them, -2x minus 7, and then press enter, and there's your first line. It plots it on there right away. So that was my really crooked black line there. The next thing you want to do is put your second equation in. For your second equation, you're going to press Tab again, and now it says f2 of x because this is your second equation. But again, that is just the same as y equals, so we will just type in the rest of the equation, -5/7 plus 1. -5/7 x plus 1. Make sure that was right. Yep. And then press enter, and there's your second equation. There's our point of intersection, but say we couldn't see our point of intersection. Maybe it was off of the graph too much. You can always zoom in and out to find it. So you would press Menu, Window Zoom, and zoom out. Then it turns, oops, I hit the wrong thing. Let's try that again. Menu, Window Zoom, zoom out, and then it turns into a magnifying glass here with a minus sign, and it's asking for the center. So it's just, where do you want to zoom out from? Well, I don't want to be down here, right? I want to be towards the point of intersection. So click somewhere around there, and you can move this around. I'm moving it with my mouse on the computer, but you can move it with these, either using the touch screen or using the arrows. So click somewhere near the point of intersection, anywhere close to it, or maybe you just would prefer to be at the origin, that's fine. And you could do that as many times as you would want, okay, in order to be able to see where it's intersecting. So maybe you want to do it a few times. Well, I'm getting kind of crazy now. So I could go back in and do window zoom, zoom in now, and get closer to that point of intersection. Okay, so you can explore moving your window around there. All right, when you're done with that, you can hit escape to get rid of the zooming. And we could now look at your point of intersection and you could figure out what it is. But at this point, I've moved my window around so much, I'm not working with -1, -2, -3, -4. I have some really funky numbers down here. But the good news is your calculator will tell you exactly what that point of intersection is. Press Menu, 6 for Analyze Graph, and guess what we're looking for? The intersection. So number 4. Whoops, except for I went back. So let me get out of there. 6, Analyze Graph, 4 for intersection. Then it pops up and it asks for a lower bound. You want to have this line somewhere to the left of your point of intersection. Here's my point of intersection. Go somewhere to the left of it. Doesn't matter where, anywhere over here. I'm going to click and then it turns into upper bound. When it says upper bound down here, you want to move somewhere to the right of the point of intersection. And notice that as soon as I do that, that intersection point pops up. But if I click, then it will permanently, not permanently, because obviously you can erase it, but then it will put that point on your screen. So then you could go back to your paper, and now we know exactly what that point of intersection is. It's 6.22 and 5.44. The calculator will round these answers, and that is okay. In the next two sections, we will find out how to get the correct answer without rounding, without using the graphing calculator. But for now, these answers are perfectly fine for us. Okay, so point of intersection, that's how you go through it. If you didn't catch any of that, of course, rewind the video, check it out again, but make sure you have all of these instructions written down. By the time you get through all of this packet, you should know how to do this very easily. You need to be able to do this both ways. You need to be able to graph these by hand and find your point of intersection, and you need to be able to do it in your calculator and find your point of intersection. When you're doing basic equations with nice, neat answers, it's easy, it should be easy to do them by hand. But if you start getting into real world data where your answers aren't going to be nice, neat whole numbers, or you have or crazy decimals or anything in your problem, for example, the very last problem on this packet deals with some 0.8s and point something else 5 maybe, that's going to be one you want to use your calculator for. It's going to make it a lot simpler to do. Okay, so you must know both ways. If you do not have a graphing calculator at home and you are working on this at home, use the website www.desmos.com. It is a graphing calculator website. I'll show you what it looks like real quick. Just click Start Graphing, and when it loads, you can just type your equations right in here. So maybe we're graphing y equals 3x minus 2. There it is. Okay, I don't know how to go about getting the exact point of intersection. Feel free to explore that if you want to. Whoops, not equals, plus. Okay, so those would be parallel lines. There would be no solution. Feel free to Google and try to find out a way to find the point of intersection on there. I'm not sure. I would stick with the TI Nspire so long as you have access to it. But if you're at home and you don't, you can always use this to help you with graphing. Okay, so that is it. That's all I've got for you. Do make sure you finish your packet completely and make sure you have your directions for this written down. All right, good luck, guys.